Hi everyone, this is Jayesh Kumar from College SBCE. We are in USN 1V20CS039. Today I am going to discuss on the given topic different types of flat plate collector. Now its introduction. Solar thermal collector. Solar thermal collectors are a special kind of heat exchangers that transform solar radiation energy to internal energy of the transport medium. The major component of any solar system is the solar collector. Solar collector. Solar collector is a device which absorbs the incoming solar radiation, converts it into heat, and transfers this heat to a fluid, usually air, water, or oil, flowing through the collector. The solar energy thus collected is carried from the circulating fluid either directly to the hot water or space conditioning equipment or to a thermal energy storage tank from which can be drawn for use at night and or cloudy days. Types of solar thermal collectors. Solar collectors are either non-concentrating or concentrating. The non-concentrating types, the collectors areas, and the areas that intercept the solar radiation is the same as the absorber area. That is the area absorbing the radiations. In this type, the whole solar panel absorbs the light. Concentrating collectors have a bigger interceptor than the absorber. For domestic or industrial water heating and space heating purpose, the solar thermal collectors are classified as a flat plate solar collector and evacuated tube solar collectors. A flat plate solar collectors. This is the how it will be look like. The flat plate solar collectors. Flat plate collectors developed by the Hotel and Villiers in the year 1950s are the most common type of solar collector which are widely used for domestic household hot water heating and space heating, where the demand temperature is low. Flat plate collector is basically a black surface that is placed at a convenient path of a sun. Evacuated tube solar thermal collector. ETC are the built to reduce the convecting and heat conduction loss. That is vacuum. That is vacuum is a heat insulator. Each evacuated tube consists of two glass and tubes. The outer tube is made up of extremely strong transparent glass that is able to withstand changing climatic conditions. The inner tube is also made of glass but coated with a special selective coating which features excellent solar heat absorption and minimal heat reflection properties. The air is evacuated from the space between the two glass tubes to form a vacuum. This is the diagram. This part is known as header pipe. This frontal part is manifold. This pipe is heat transfer fin. The next to it evacuated tube, and this is a thin yellow pipe is called heat pipe, and this is the mounting frame. Component of the solar plate collector. They consist of mainly a dark flat plate absorber, a transparent cover that reduces the heat losses called glazing, a heat transport fluid, air, antifreeze or water to remove heat from the absorber. Heat insulating backing, flow package and enclosure. Absorber plate. It is usually made up of a copper, steel or plastic. The surface is covered with a flat black material of high absorptance. Now, flow passages. The flow passages conduct the working fluid through the collector. If the working fluid is a liquid, the flow passage is usually a tube that is attached to or is a part of the absorber plate. Cover plate. Cover plate. To reduce the convective and radiative heat losses from the absorber, one or two transparent covers are generally placed above the absorber plate. They usually be made from glass or plastic. Insulation. These are some materials such as fiberglass, and they are placed at the back and the sides of the collectors to reduce the heat losses. Enclosure. A box that the collector is enclosed in holds the components together, protect them from weather, facilitate installations of the collectors on a roof or an appropriate frame. This is the typical diagram of flat plate solar thermal collectors. This is the collector efficiencies. The basic method of measuring a collector performance is to expose the operating collectors to solar radiation and measure the fluid inlet and outlet temperatures and the fluid flow rate. The useful gain is Q equals to m dash Cp bracket T naught minus Ti, equation energy gained by liquid, where m dash is equal to fluid mass flow rate kg per second and Cp is equal to fluid specific heat by joule per kg degree Celsius.